Okay guys, well I just wanted to cover these last few slides on a short video for the metabolism notes here. So you guys are able to take a look at these and you're able to get all this information that you might want to use for the concept maps. And that'll give us the time on Monday to do everything we need to do for the TBL day on the endocrine system, as well as on Wednesday to do the review. So I won't be going over this stuff in class, but I'm just going to show you all of it here. So this is where we left off on Friday, after Friday morning, and really what we're looking at here is where all the ATP comes from as you go through the oxidative system, and then also where we get the NADHs and the FADH2s and where it all comes from. So as you know, we start in glycolysis. Glycolysis again is glucose to pyruvate. So going just from glucose to pyruvate, we use 2 ATP, right? You guys know that from glucose to pyruvate. For going from glycogen to pyruvate, we only use 1. Okay, but we make 4 ATP. So now we have a net of 2 ATP so far, and we actually make 2 NADH molecules. Okay, so we got 2 NADHs. We know those are going to end up going in the electron transport chain to help us make ATP. Now just going from pyruvate to acetyl-CoA, so that's that step after glycolysis, but before the Kreb cycle starts. We actually make 2 more NADHs at that point. And so then once we start the Kreb cycle is going to turn 2 times for 1 glucose molecule. But with each turn, we're going to make 3 NADHs, 1 FADH2s, and 1 ATP. But since we go 2 turns in the Kreb cycle for each glucose, we're going to times all those numbers by 2 there. Okay, and then finally, in the electron transport chain, for every NADH molecule, we get 2.5 ATP, and for every FADH2, we get 1.5 ATP, and that's just because the FADH2 drops off the electrons and the hydrogens later in the electron transport chain, so it doesn't have as much time to build up as much hydrogen in that concentration gradient. So that's that. So then if we go ahead and add all these things up, so this is a figure right from your book, but it's a very nice and helpful figure. So total ATP, net ATP production in glycolysis is going to be 2 ATP because we make 4, but we use 2, so we get 2 net there. Okay, so from our 2 NADHs that come out of glycolysis, we get 5 ATP because that's 2.5 times 2. Okay, then we got 2 NADHs coming from the pyruvate to acetyl-CoA. Again, 2 times 2.5, that's another 5 ATP. Okay, so then we've got 6 coming out of the Kreb cycle because of the 2 turns. 6 NADHs, 2 FADHs, you add those up, that's 15 ATP, 3 ATP, and then the 2 ATP that are made right in the Kreb cycle. You add all those up, you get 32 ATP. That's where the 32 ATP come from. And so this is where we get the number 32. Obviously, if we started with glycogen instead of glucose, we would have 33 ATP. Okay, and this is just going to add it up for you again. So in total, we have 10 NADHs. So 10 times that 2.5 is going to give us 25 ATP. So the vast majority comes from that right there. Again, 2 from glycolysis, 2 from pyruvate to acetyl-CoA, 6 from the Kreb cycle. And then these 2 FADH2s, 1.5 times 2, it's going to give us 3 ATP. Again, 2 from the Kreb cycle, 2 in glycolysis, and actual total, 32. So far we've just really been talking about the oxidation of carbohydrates to drive the oxidative system. But the oxidative system can also use lipids and proteins. So this slide is looking at how that can happen. You can see proteins coming in over here. We'll look at that more on the next slide. But as far as the oxidation of lipids, you can see that triglycerides are the main lipids that we use, and those are broken down into glycerol and fatty acids. The glycerol enters up here into glycolysis, and then the fatty acids get turned into acetyl-CoA through a process called beta oxidation, and that starts the Kreb cycle. A couple of the major differences between the way that fats are broken down versus carbohydrates. One is the amount of oxygen needed to break down fat versus carbohydrate is a lot higher, and you can see that down here in the equation. And the other is a number of ATP you get. And so if you look at these equations, this is a chemical formula for glucose. You can see that it takes 6 oxygens to break down 1 glucose molecule, and you get 6 CO2, 6 water, and then you get the 32 ATP that we've been talking about. But with fat, here's a fat molecule, palmitic acid. It takes 23 molecules of oxygen. You get 16 molecules of CO2 and water, and then you get 106 ATP. So this is where fat is a much more powerful energy source. You get a lot more ATP with it, but it takes a lot longer to break down. This process up here is a lot longer than it is to break down glucose. And the one thing we'll talk more about later in the next section after the first exam is this idea of RER, which is a respiratory exchange ratio. And really what that means is you take the number of CO2 produced and divide that by the amount of oxygen used to break down a fuel, and that ratio is going to be RER, and that's going to give us a good idea of what fuel we're burning. And so you'll see the ratio of O2 to CO2 with carbohydrate is 1, the ratio of CO2 to O2 with fat is actually about 0.7. If we go 16 divided by 23, it's about 0.7. And so we'll actually get that RER number when we use a metabolic cart, and we'll get to be able to tell what fuel the person is burning who has a metabolic cart hooked up to them. So we'll do that in a couple weeks. Okay, and this slide is just showing the way that protein is broken down. And really the way this works is protein has to be broken down into its individual amino acids first, and then each amino acid kind of enters the Kreb cycle in a different place, as you can see here. You definitely don't need to know the details of this, but this is just showing how each amino acid can kind of get broken down into one of these intermediates of the Kreb cycle, and that's how protein is broken down. And then after that, it's just the same as the other ones as we go through the Kreb cycle and electron transport chain and everything else. And I'm not going to go through this, but this is just a way for you to review the energy system, so you can go through each of the 3 energy systems, fill in these different categories just as a way to review this. All right, and that's it.